Hey, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 lesson videos. Today we're looking at Unit 3, Lessons 6 and 7, which is about using equations to solve problems. So in this unit we've been talking about how we can solve these linear equations. In this particular lesson, we're applying that to some problem situations. So if we start with this first example, it says a classmate tells you they are thinking of a number. The quotient of this number and 5 plus the product of 3 and the number is equal to 1. And they want us to write and solve an equation to find that number. So let's first of all, let's define a variable. We're gonna use n to represent the number that we're trying to find. So n is our variable. We know that we need the quotient of this number and 5. Quotient is the solution to a division problem. So the quotient of this number and 5 means we're taking n and dividing it by 5. So that is the quotient of our number and 5. Then it says to that we need to add the product of 3 and the number. Well, product is the solution to a multiplication problem. So again, some vocabulary there. Quotient is division, product is multiplication. We want the product of 3 and our number, so that's 3 times our number, which is n. And when we add those together, it tells us that that needs to equal 1. All right, so this is our equation. And so now we want to solve our equation for n. So to solve it, we're going to, first we want to work on isolating our variable. Well, a few ways we can go about it here. So we have our variable showing up in two terms here. We have the n being divided by 5, and then we also have it being multiplied by 3 here. So we can start with either one. I'm going to start with the division by 5. I want to undo that division. That means I need to multiply by 5. But since these are both terms are on the same side here, if I do that, I need to do it to both of these terms. So I'm going to multiply everything on this side by 5. I'm also going to multiply everything on the other side by 5. So if we distribute here, 5 times the n divided by 5, those 5's divide to 1, just leaves me with n. When I take 5 times the positive 3n, 5 times 3 is 15, so that becomes 15n. And then 1 times 5 is 5. Now I can add those two n terms together because they're like terms. Remember, this is the same as having 1n. So 1n plus 15n is 16n. So 16n is equal to 5. And then finally, to solve for n, right now that n is being multiplied by 16. We want to undo that multiplication by dividing. And I'm out of room here, so I'm going to write that over here. So 16n divided by 16 is just 1n, or n. And then 5 divided by 16, I'm just going to leave it in that fraction form of 5/16. That's not a fraction that I can simplify any further. And so that is the number that they were thinking of. Wasn't very nice of them to think of a fraction, right? But that's how we would go about solving that problem. All right, number 2 here says write and solve an equation for another situation. It says the sum of a number and 1/2 of the sum of that number and 4 is equal to -6. All right, so let's start again by defining a variable. This time we'll use x. We can use really any letter to represent our variable. And so it says the sum of our number and 1/2 of the sum of that number and 4. So we're going to take our number and we're going to add it to 1/2 of the sum of our number and 4. So sum means addition. So the sum of our number and 4, that's x plus 4, we're taking that times 1/2 because it says 1/2 of that sum, and then adding it to our number. That needs to equal -6. so this would be our original equation. And so to solve for x, I want to get those variables by themselves. Right now I have it in two places. I would start by distributing my 1/2 here. So I've got 1/2 times x, which is 1/2 x. And I have 1/2 times 4. 1/2 of 4 is 2. So then, like terms, I have an x here. Remember, that's 1x plus 1/2 x. So if I add those together, that's 1.5 x. Or as an improper fraction, that would be 3/2 x plus 2 equals -6. I'm going to rewrite this over here just so I have some more room to work. So right now we're at 3/2 x plus 2 equals -6. To get that x by itself, I need to undo that addition. So I'm going to subtract 2 from each side. That gives me 3/2 x equals -6 minus 2, or -6 plus a -2, which is -8. All right, so right now that x is being multiplied by 3/2. So to undo that, I need to divide by 3/2. Well, if you remember dividing fractions, to divide by a fraction, it's the same as multiplying by the reciprocal of that fraction. And reciprocal means you flip that fraction. So to divide by 3/2, that's the same as multiplying by 2/3. So I'm going to multiply both sides of this equation by 2/3. And when I do that on the left side, I'm just left with 1x, or x. And on this side, when I take -8 times 2/3, remember that's -8 over 1, we multiply across. 8 times 2 is 16. 1 times 3 is 3. So this would be, x would equal a -16/3. So that would be our process for working through that equation and solving it for x. All right, and then our last example here, they've given us the equation to begin with, and they want us to solve for our variable of d. So we have 5d plus 12 equals 9d minus 4. So here I have a variable on each side, and I have my constants on each side. So I'm going to, I need to get my variables on one side, my constants on the other, and I can work either side. I'm going to go ahead and I'm going to get my variables on the left side, get my constants on the right side. So I'm going to start, right now I have a positive 9d over here on the right. I'm going to go ahead and subtract that 9d, undo that addition that it has over there. And if I do it on one side, I have to do it on the other side. 5d minus 9d is -4d. I have a plus 12 still there. And then here, 9d minus 9d, those zero out, and I'm left with -4. Now I still want to get this d by itself, so right now I'm adding 12. I want to undo that addition, so I'm going to subtract 12 from each side. Leaves me with -4d here. And on my right side, -4 minus 12, or -4 plus a -12, that's -16. And then finally, that d is being multiplied by -4. I'm going to undo that multiplication by dividing by -4. And so that leaves me with d equals -16 divided by -4 would be +4. Same signs. When we're dividing, it's going to be positive. So d equals 4. If I wanted to check my work, I could plug that 4 back into the original equation. I'm just going to talk through it rather than writing it. 5 times 4, 5 times d, 5 times 4 is 20. So 20 plus 12 gives me 32 on the left side. On the right side, 9 times d, well, 9 times 4 is 36, and 36 minus 4 is 32. So we do get a true statement when we check plugging that back in. All right, that's all I've got for you today. Appreciate you taking the time to watch. And as always, if you do have questions, please let me know. Thanks. Have a great day.